Okay, so welcome to this particular session. So in this session, we are going to learn this orthographic projection. And so basics of orthographic projection I have already discussed in the start of the first chapter. So I will just revise some things, and then we will start with some problems. So you know that the different types of lines that outline the projection line, hidden line, and the center lines. And so you can see here the different applications of the line. So you can see this outline is there with a dark continuous line. Here it is a hidden line, which is dotted. This one is a center line, and whatever the red color indicates that these are the projection lines. Usually in the drawing we are using 09 color for drawing the projection, and the others are dimension lines. So these are the different applications of the line. So what is meant by projection? Everybody knows that. In the engineering drawing, the word projection means the image of, or the act of obtaining the image of an object is called as a projection, and the technical people often refer to that image is as a view. So this is the best example. It is a light source, the object, and the screen. So this light source emitting, it is called as observer, then object, and the screen is called as a plane. And the image, whatever observed on the screen, that would be the your view. Okay. So orthographic projection. So you can see this school bus, and this is having 6 principal views, and you can see here the bottom view, left hand side view, front view, the right hand side view, as well as back view is there, and the top view is also there. So basically what is mean by orthographic projection? Conversion of 3D drawing into the 2D views. It is what the uh, orthographic projection. Okay, so basically conversion of 3D object into 2D drawing is nothing but the orthographic projection, and the reverse of this means 2D drawing into 3D view. It is called as a isometric projection. So any object can be represented in a 3 basic views. One is a front view, top view, and any one of the side view, right hand side view or left hand side view. If you draw these 3 views, then that object will be very clear to reader, or maybe um, it is very clear to the those who are going to learn that, or those who are going to read that particular drawing. Getting? So the bottom view and back view is not necessary at that time. So for any object there would be a 6 different principal views, and these are whatever you are seeing on this screen. Now I'll just talk about the theory of the projection. So here you can see, suppose how to take the projection on the plane. So the observer is object is there, and that line of sights are called as the projection lines. And when all the corners are projected on the screen or that plane, then when you join it, that that one profile is generated on that particular plane, and that profile is called as a view, or maybe it may be front view, top view, side view, and whatever the lines we have taken from the source object, so that is called as a projection lines. Okay, so here there are ortho means straight. Everybody knows that when we use the ortho button on the AutoCAD, so that lines you are going to draw, that would be straight. So that is why it is called as a straight. Ortho means straight. Okay, so there are basically 2 planes we are going to learn here right now, that are the frontal reference plane and horizontal reference plane, or this is called as a vertical reference plane. Okay, usually in the first angle projection method, front view is observed in the front view, frontal reference plane, and the top view is observed on the horizontal reference plane. Okay, so it is called as a vertical plane of projection, and this is called as a horizontal reference plane projection. So in the pictorial view, you can see this one is a frontal reference plane, vertical plane, and horizontal reference plane. And when we see this object, you will, when you take the projection on the both the planes, it is necessary to rotate this horizontal plane by 90 degree. Usually in the, I'll show you in the directly first quadrant, there are basically 2 quadrants or two methods we are going to use. Okay, so first quadrant, second quadrant, third quadrant, and fourth quadrant. So there are two methods of drawing. One is the first angle projection method and third angle projection method. So in the first angle projection method, the object is kept here, and in a third angle projection method, object kept in third quadrant. And then horizontal plane is rotated by 90 degree in a clockwise direction. So that you will get the front view in the VP and top view in the HP. So below the XY line, you will get the top view. In the third angle projection, the top view will be getting here in the HP. So if you rotate by 90 degree, so that top view will be above XY line and the front view will be in the below the XY line. But in the education system, we are going to use this first angle projection method. Okay, so you have to concentrate on the only first angle projection method. So you can see here the first quadrant and the third quadrant. Okay, so this is called as a third angle projection method, and uppermost is called as a first angle projection method. Okay, so you just check out here. So observer is here, and then that the top view is observed here. So the object when it is placed in the first quadrant, so this horizontal plane is required to rotate by 90 degree in a clockwise direction. Okay, so that's why you will get the front view above the XY line and the top view below the XY line, and in between that you will find the some projections. Okay, so I will quickly go through this. So this is, you can see here the demonstration of the how that horizontal plane is going to be rotated. Okay, so this is what it is required to represent. Getting now, uh, here it is must to know the particular side view, the types of side view. So there are two types of side view. One is a right hand side view, and the second one is a left hand side view. Okay, so right hand side view means what and left hand side view means what? Suppose the object is kept like this, and this direction is the front view. Okay, so observer is looking from this side, and it is required to draw on the left side. Okay, if it is look from the right, it is required to draw on the left. And if it is side view, and if it is observer is looking from the left side, it is required to draw at the right side. So you will find this front view from this direction, and it is required to draw here. Okay, and you can find this side view from this direction, and it is required to draw in the this side. So you will get the side view in the left side. So that's why it is called as the left hand side view. Left hand side view, and it is required to draw on the right side. It is required to draw on the right side. So left hand side view is always at the right side. Okay, so position of the side view is going to be changed according to the direction. So you can see here it is a left hand side view looking from left side. So you will you're supposed to draw this side view on the left side. Okay, left hand side view is at the right side. Okay, so front view you will get on the left side. Getting? So similar to that, you will get the front view and top view, and this one is the side view. Okay, so this is a plane of projection. You will get the side view in the plane of projection, and then this one is a front view in the VP vertical plane, and this one is a top view in the horizontal reference plane. Okay, so similar to that, you can see here this when the object is placed in the third quadrant, it is required to rotate by 90 degree. So you will get the top view in the above XY line, and front view is in the below the XY. You're supposed to remember these things. We are following only first angle projection method, not third angle projection method. So it is for just information. Okay, so now you can see the left hand side view you will get on the below the XY line, side by front view, side to the front view, and the top view is above the XY line. Okay, so this is what the third angle projection is. In a first, there are representation of also first angle and third angle symbols. So you can see here, this is the first angle projection symbol. So observers here. So this one you will get the front view. Here you will get the top view for this particular diagram. And when it is a third angle projection method, you will get the front view here and top view here, and it is rotated by 90 degrees. So you will get the top view here and front view here. Okay, so this is what the first angle projection symbol and third angle projection. Usually this you might have seen on the standard sheet, which is available in the Moodle, or when you use this while drawing in the practical. Okay, so this is the two symbols of the projection, first angle projection and third angle projection. So there are types of um, different types of surfaces also. So in the object there are different types of surfaces. One is a principal surface, another is inclined surface, skew surface, and curve surface. What is that? We will just learn. So this is what the principal surface. These are parallel or perpendicular to the reference planes. Okay, so it is either parallel or maybe perpendicular to the reference planes. So you can see here this plane is parallel or perpendicular to the reference plane. Now this one, inclined surface. So you can see here, this is inclined to any one of the surface. When the plane is inclined to any one of the surface, so that can be considered as a inclined surface. Okay. Then this one is a skew surface. This plane is inclined to all the surfaces. So it's kind of a pyramid, you know. So the pyramid, when you look from the any side, so you will get the triangle. Okay, any side. When you look from the top, you will get the triangle. When you look from the front, you will get the triangle front this side. And when you look from the side also, you will get the triangle. So this is called as a skew surface. Okay. Then this is a curve surface. So basically, when you see the curve surface, you will get the rectangles in the front side or side. And when you look from the top, so basically it's a kind of a circle, na? So it's cylinder. That's why when you look from the top, you will get the circle. Okay. So here we are going to learn the concept of hidden line. Look at here. Suppose before going to that, let me tell you that here it is an object and here it is an orthographic view of that particular object. Here is a front view, here is a side view, and here is a top view. Okay. So this arrow indicate that in the examination you will be provided only one arrow, and that arrow indicating that the observer is from this side. Means you will get the front view from this arrow side. You will get the front view from this arrow side only, and the other side you can consider as a side view. So here the observer is looking from the right side. That's why you will get the right hand side view on the left side. Okay, so there are two types of side view basically. One is a right hand side view and another is a left hand side view. So here in this diagram you will get the right hand side view. Why? Because observer is looking from the right side, so you will get the right hand side view. And when you see this object for the front view, it is from the left side, so that's why it is required to draw on the right side. Looking from right, drawing at the left, looking from the right, drawing at the left, and looking from the left, it is required to draw at the right. So the front view is looking from the left side and it is required to draw at the right. Okay, and the side view is looking from the right, required to draw at the left. So it is a right hand side view at the left side, and top view is always below the front view. Always do remember. So position of the side view and top view, it may changes. So once you change the position, if it is looking from this side as a front view, so this side view would be on this side. Okay, I will take you let you know another example. So before that, we are understanding here the concept of hidden line. Okay, so this is what the orthographic view. When you look from the front, you will get one rectangle here, 1, 2. Then when you look from the top, one rectangle here, one rectangle here. This is what the top view. And when you look from the side, you will get the L shape. So this is what the L shape. Now when I keep this object in another direction, okay, so what happened? This step is not visible clearly. So this is what the hidden line. Okay, here, this line. Okay, C line. So this BC line is hidden here, not visible from the front. So that is what is required to draw by hidden line. So how it is required to draw? So you can just take the projection from this side and you can draw the hidden line. So it indicates that BC is a hidden line. So this is what the concept of hidden line. So one more example here we will discuss. Now look at here. This is the orthographic view of this object. Now here also the observer is looking from this left. So this is what the front view, and this direction is the side view. So here also observer is looking for side view in a right direction, right hand side. So that's why you will get the right hand side view on the left side. So when that observer is looking here, so this EF line is hidden. But EF is overlapped by BC visible line. So whenever the hidden line is overlapped by some visible line, always required to draw the visible line. So BC is hidden here, but it is overlapped by EF. Sorry, EF is hidden line, but it is overlapped by BC line. So that's why it is required to draw visible line. So that time you do not supposed to consider that particular hidden line. Do remember. Also here, this one also hidden line. This one as well as this one. So this one is also hidden line. But this is also uh, overlapped by this particular line. So that's why it is also required to draw by visible line. Getting? So, so this is what the concept of hidden line. Similar to that, when the object is like this cylinder, there is a inner hole. Inner hole. Okay. Now that inner hole, you can see that is required to show by hidden line in the front and side views, because these are not visible. This one is not visible. So that's why you can take the projection from the inner hole and you show it by hidden line. It indicates that the hole is throughout. If I show it up to the middle one, hidden lines, it means that this hole is up to the center line. Getting? Look at here. This one is also. If you see from the front, it is clearly visible, inner hole. So there would be two rectangles at the both side. But if you see from the side, this line is not visible. So that's why for the inner hole, I'm going to take the projection and it is required to show it by hidden line. Okay. And if I kept this in a reverse way, so what happened? Both the lines are not visible of the inner circle. So that's why we can take this upward direction and show it by hidden line. So same way, whenever the assembly is there, you supposed to consider it is a whole object. Whenever the object is prepared with some 2 to 3 components, then you have to consider as a whole object, and then you have to draw the this particular orthographic projection. So here also the front view is from the left side. Okay, left side. So that's why it is required to draw on the right side, and side view is from the right side. So that's why it is required to draw at left side. So this is a right hand side view on the left side. Okay, so when you see from the front, this square is visible, this square is visible, this triangle is visible. Getting? And then if you see from the top, you will get this square, and this rectangle. Okay, so you will get this one, and you have to take the projection from the top. Similar to that, when you see from the side, 1, 2, only 2 rectangles are visible. So that's why you require to draw only 2 rectangles. Getting? So object as a single piece you have to consider. Already have told you. Now this object. So if you see this one, this part, some parts from the objects are removed. Okay, so this is the basic part or raw material. Then some part is removed and this object becomes like this. And here the front view is also from the left side, and the right hand side view is there on the left side. So here what we have to do, suppose if you see from the front, you will get the 2 circles, but one step is there. So one line is visible here, one line is visible here, so that you can draw it here. But if you see from the top, one rectangle for this, then these 2 rectangles, one rectangle is here, these 2 rectangles, and this one rectangle. Getting? But the inner circle, whatever there, that is hidden here. So that's why, that's what here it is required to draw by hidden lines. And if you see from the side view, you will get the L shape, and one hole, this inner hole is hidden here. So that you have to show it by hidden lines. Okay. Now you can see here, whenever the assembly is like this, when object is placed like this here, and when you see from the front, so you can consider that is hidden here. But when that object is like this, you do not supposed to consider that this part or that bolt is here. So you have to consider like this. Getting? So when you see from the front, so you supposed to draw like this part separate, this rectangle and this rectangle. And when you see from the top, you will get the 2 rectangles, this rectangle and this rectangle. Getting? So this is what the when the object is like this. Okay, so you can see here the object is here and the square hole is inside that. Okay, and when the square hole is inside that, what happened? When you see from the front or side, you will not getting that square hole. It is visible only in the front top view. Getting? So that square hole, you have to take the projection and you have to show it by hidden lines. So there are three views of the drawing. Already have told you that this is the front view, side view, and the top view. So the three directions are given here, but you do not supposed to consider that three directions. You will be provided only one direction during the examination. So you have to consider that one direction is the front view direction. Getting? So if you see this box or cube, so you will get the all the rectangles from front, top, and side. So I'll just discuss one example here. The question is in front of you, and the front view is from this direction. Okay, so this arrow indicates that the front view. Getting? So you will get the left-hand side view on the right side. You will get the left-hand side view on the right side, and this front view on the left side. Getting? So here it is a left-hand side view. In the last some examples, you might have seen that right-hand side view, but here it is a left-hand side view. So left-hand side view is always at the right side. Getting? So how the projections are required to be taken? So this is front view. So you can take the projection on the frontal reference plane. Okay. So you will get the shape like this. You will get top view like this. So you have to rotate it like this. Then the side view, you have to take the projection like this. And then this is the left-hand side view on the right side. So you will get the projection like this, orthographic projection, front view, top view, and this one is side view. Okay, this one is the right hand side view. So now this example. So there are different surfaces. The whatever the yellow surface indicate that it is visible from the top side. Okay, so this one is the top view for this particular. So this rectangle is here, this circle is here, then this shape, one like shape, this you will get here. Then so this blue color indicate that the front view. Okay, so this surface, green surface, is visible from the top as well as front. So this one is a front view. Then side view, that red color indicate that the side view. So here it is one surface and one surface is here, triangle. Now this hole is not visible from the front and side. It is visible clearly in the top. So that's why it is clearly mentioned here in the top view. And when that hole is not visible in the front, so this hole is present here. So we have to take the projection at the front surface, front view, and we have to show it by hidden line in this plate as well as this plate. Similar to that, it is also visible in the not visible in the side view. So we have to show it by hidden lines in the side view. Similar to that, this corner is not visible from the front view, side view. Okay, so in that you have to show it by this line. Okay, so this line, hidden line, this one as well as this one, you're supposed to show it by this corner as well as this corner. Throughout, show it by hidden line. And when you see from the top, this corner is not visible, so I'm going to take the projection from this line and you have to show it by hidden line. Getting? So you can see here one of the example how it is required to draw. So let us consider here in the x direction is a front view. So this is a front view. So you will get the right hand side view on the left side. Okay. So this is the right hand side view on the left side, and this is one is a front view. So and how this is how it is the projections are taken. So always do remember projections are very important. We are using projection method to draw the orthographic projection. So hence that's why you have to show all the projection in the diagram when you draw the orthographic projection. If you are unable to show the projection, you will lose your marks. Okay, so always do remember the projections are very important, and it is always required to show it by 09 color in the AutoCAD. So one of the example here, so you can see this is a front view. So you will get the left hand side view. You will get the left hand side of view for this on the right side. Okay, so still there are 8-9 minutes. So I will just share the another screen, and once you complete this session, immediately I will create one more session, so you can just log in again into that one. Okay, So I will go to the next slide. Okay, quickly I'll show how to draw this one. So in the orthographic projection, basically you have to decide the position first. Front view, top view, side view, whether it is the right hand side view or left hand side view. So these are the some steps to learn the orthographic projection. And then determine the dimension. What would be the maximum length, maximum width, maximum height. So for the front view, you have to consider length and height, top view length and width, and for the side view, height and width. So these dimensions you have to consider. Then after that, you have to draw the rectangles. The basic part of that means you have to prepare a block for the front view, top view, and side view. Means you have to set the limits for each and every view. Then draw the center lines, or you can draw then cylindrical parts or circles, holes. After that, you can draw in the series like this: circle, arc, then straight line, then small curves. Then pair the views and also check the hidden lines. Then dimension views completely. Give the dimension to that views completely. And after that, then section and then other drawing you have to draw. Getting? So here I have some views. So you can see here this object. So object is looking, this indicate that the front view. Okay. So whether you are you getting right hand side view or left hand side view? Can anyone tell me on the chat room? Whether in this diagram you will get either you will get the left hand side view or right hand side view. Yes, you can type in chat room. Yeah, Shantanu Wag has replied. So here it is, you will get the right hand side view. It is on always at the left side. So purposefully I have shown it here. Wrong answer. Here it is a left hand side. So this is a wrong answer. Getting? So front view should be on this side and left hand side view on the means right hand side view on the this side. Okay, the correct answer is there and the top view is here. So this is wrong answer. Getting? So in examination, if you draw like this, then the marks will be cut. Okay, probably half of the marks will be cut. Means the question will be asked for this orthographic projection is for 24 marks. Do remember 24 marks single question. Okay, and then from whatever you have drawn, that some part of the marks will be cut for that, even though your answer is correct. So position of the views is very important. So at the start only you have to decide the position of the views. Front view, where should be front view, where should be the top view, where should be the side view. Getting? So here also you will get the right hand side view, but I have purposefully drawn it's wrongly. So if you see from the front, you will get this portion. So you have to show it like this. If you see from the side, this one rectangle and this small rectangle. If you see from the top, you will get only one rectangle, this one. Okay, but the positions are wrong here. Okay, so this front view should be on this side. Looking from this side, drawing at this side. Here is a y-axis and x-axis. Getting? So if you look from the left, you have to draw it on the right, and if you look from the right, you have to draw it at the left of this y-axis. Getting? Now next part, similar to this one, here also I have drawn wrongly the side view. So front view is here. Only check out the views. Do not consider the places. So here it is a L shape when you look from the front. Top, this rectangle, and then side, this rectangle, this rectangle. Here it is wrong. It should not be here hidden line. It is completely visible. So there should not be any hidden line here. So look at here. This is what I will just quickly go through this. The positions are wrong here. Here it is also right hand side view. Okay. And the different views. Now you can see this one, this part. So here it is a right hand side view. It is always required to draw at the left. Here it is correct. So if you see from the top, this rectangle and the base rectangle. So these two rectangles are visible and these are the slant edges. So it is a like kind of frustum. Okay. And if you see from the side, you will get the shape like this. And if you see from the front, you will get the shape like this. Then here, when you look from the front, you will get the half circle here, half circle, and in between that one step, and one from top you will get one rectangle, and this one is a L shape you will get from the side. So there are some examples. We will start with some examples. You can see here, these are the some examples how the objects are like this. So this kind of objects will be asked in the examination. So we'll start with the simple one. We'll start with this one, object number 2. So you just capture this object and let me know what would be the maximum length, maximum width, and maximum height. There are only 2 minutes are remaining. So before that, we can calculate the dimensions. And once you logged out from this particular session, immediately you can log in into same there. Immediately you can log in. I will create one more session so we can solve this question on this particular session. So now the observer is here. So you can tell me whether it is a right hand side view or left hand side view. In chat room, you can mention your answer, whether it is a right hand side view or left hand side view. S, whether it is a right hand side view or left hand side view. The front view indicate here. Okay, so right hand side view on the left side. The Mansi Shah has replied here. So you will get the right hand side view on the left side and the front view on the right side. Getting? So always do remember, length you will get in the front view direction, height here, and the width you will get in the side view direction. So can you tell me what would be the maximum length, maximum width, and maximum height of this particular object? Yeah, it's Manish. Sorry, I talk Mansi, na? So sorry. Yes. Wag has replied that the maximum height is 60. B for length is 45 and the width means you can refer W for that. So this would be the 60. Okay. So this would be the 60. Width is 60, height is 60, and this length is 45. Okay. So that we are going to consider, and we are going to solve in the AutoCAD. So the session is going to over here, and then immediately I will create next session. You can just log in.